Okay, we'll work through the solution to quiz 10 for statics, MENG 1230. We have this truss here. There's a load applied at D going straight down. It's symmetric, so we have a pin connection at A. It is a lowercase a distance from that point to D, another lowercase a from that point to C. Then we have our vertical dimensions here. It's 3/4 A, 1/4 A. So it's pretty clearly seen that AB equals BC, AD equals CD, and BD is unique here at the center here. So that's our truss. We can also look and calculate a couple angles here. So I'm going to call this one phi, and that's going to be the arctan of 1/4 A over A, so that's 0.25, and that works out to be 14 degrees. And then this is A, height of A over A, so this angle here, theta, equals 45 degrees. Alright, looking at the problem description, we're told that if lowercase a equals 10 feet, what's the greatest load P that the truss can support if A, B, and BC can support a maximum of 800 pounds in compression? So that's part A. Part B, same thing, only we're looking at AD, DC, and BD, and those are 1,500 pounds. Our hint here is to solve for each member in terms of P and then substitute to find our numerical value. Alright, so what is our approach? Step 1, we're going to find the reactions. And you can see here in the rubric, or the how you get your points, we get 3 points for that. Then we'll do method of joints. We'll have to do 2. So we'll probably start with A, and then we can move on to B or D on our choice here. So I'll get us each of those members, so another 3 points, and then 3 solve for P. We get 2 points for each of those, so we get 3 plus 3 plus 2 times 2 equals 10 points total. Alright, so step 1, our reactions. Let's take our moments around A. Some of the moments around A, step 1, is going to equal 0. So we're going to have negative P times A, and that's a clockwise, so it's a negative moment, plus our normal force at C times 2A. So NC equals PA over 2A. NC equals 1/2 P. There's our reaction there. Sum of the forces in Y equals 0. So we have 0 equals negative P plus 1/2 P plus FAY. FAY equals 1/2 P. And then finally, sum of the forces in X equals 0. 0 equals FAX. There's only that possible contribution in the X direction. So FAX equals 0. So there's our 3 reactions. Alright, so then we can move on to our method of joints. Method of joints. Starting at joint A. So what do we have there? We have AB, we have AD. I'm going to make these both tensions. AD, we have FAY, and there's no X component. So it's pretty clear that AB and AD can't have the same direction. They can't both be compression or tension members. One has to be one and one has to be other. We also had a hint in the problem description that AB is a compression member. In compression, AD is in tension. So we'll look through that. So if I switch that around, I'm going to stay with this sign convention. I'm going to draw all things in tension so that a negative sign indicates compression. So we're going to do sum of the forces in Y equals 0. 0 equals 1/2 P plus sine 45 degrees AB. AB again, that direction we drew on our diagram here. It's total of A over A, so that's 45 degrees. And then we have our other one here, 14 degrees for AD, plus sine 14 degrees AD. So if we'll leave that here for the time being, and we'll do our sum of forces in X equals 0. So we're going to have 0 equals cosine 45 AB plus cosine 14 AD. AD equals negative cosine 45 degrees AB over cosine of 14. Excuse me. We can substitute that back up here. So I'm writing everything in terms of AB. So we get negative 1/2 P equals sine of 45 AB plus sine of 14 over cosine of 14 times negative cosine 45 AB. AB, if we substitute values at this point, find AB equals negative 0.9439 P. So there's AB in terms of P. Substituting that part into AD. AD equals 0.6872 P. And our directions there, this is going to be in compression, this is going to be in tension. There we are. Second joint, I'll do D. So we have, this is AD, this is, what is it, DC, BD. So these are pulling on these joints here. And then we have P coming down. Sum of our forces in Y equals 0. 0 equals negative P minus 2. So AD and DC are equal due to symmetry, so I'm just going to multiply that times this, 2, 0.6872 P plus BD. BD equals whatever that is, 1.3 something. Negative, negative, positive. So FBD. Where did I end up with that? Oh, and times their, sorry, sine of 14 in here. That's what I skipping, saying 14 degrees, right? So that's the small component there. So if I slide these over to the other side, I find BD is 1.333 P, and that's in tension, as we'd expect. So that's our three unique values. So looking back up at our approach here, we found our reactions, we found our joints for our three unique members. Now we need to find P for these limited cases. So for our compression member, we only have this one case. So I'm going to take that, say AB equals 800 pounds. P equals 800 over 0.9429. So that goes to 848 pounds. So that's our value for the compression case. And then for our tension case, it's a little more tricky. We have two values of tension. If we pick this one, it's a smaller value of P. So if we set that equal to 1500, we'll find something much greater than 1500 here, almost, what is that, 4/3 or so, that value of 15, versus if we set this one equal to 1500, we're going to find P is something less than 1500 since we have a multiplier greater than 1. So this is our limiting case here. Remember, BD is our limiting case. So we have 1.333 P equals 1500 pounds. So in that case, P equals 1,128 pounds. To three significant figures, we have 1.13 kips. So there's our value, and that makes sense. It's more limiting in compression. If we come back and reinforce those members somehow, so that now our tension members are a limiting factor, we find that we can support a greater load. And that was our solution for P.